Now we have Martin's rule or matrix method, which is given by three linear equations. I've written three linear equations. I'll write a matrix A, which is denoted by A, writing 5, 2, 1, 3, 1 and 2, 1, 3 and 4. After that, I'll write X, which is given by X is equals to the variables, that is X, Y and Z. You'll always write this in vertical manner, and after that you'll write B. B is equals to the constants on the right hand side of the given equation, 16, 19 along with 25. So firstly, before you find my formula to find the variables X, Y and Z, X is equals to A inverse into B. To find out A inverse, I'll find the determinant of a given matrix. Determinant of a given matrix is given by 5, 3, 1, 2, 1, 3, 1, 2, 4. I'll solve this. To solve this, I'll write this as 5, 4 minus 6 minus 3. Why? Because it is placed in the first row and the second column, so it has become minus, which we have already done in determinants. So leaving the identical column of it, row of it, this becomes minus 3. This becomes 8 minus 3 along with plus 1. If you take up 1, leave this, you are left with 4 minus 1. So you'll get this as minus 2, that becomes minus 10. You'll get 5 3s are 15, that is minus 15, plus 3, that is equals to minus 25, plus 3, that is equals to minus 22. So A inverse exists. So since A inverse exists, now I have to find the A inverse. To find the A inverse, everyone knows A inverse is equals to adjoint of A divided by the determinant. To find out A, after this, determinant of A you have already found. To find the adjoint of A, which is given by A11, A12, A13, A21, 22, 23 and 31, 32 and 33. Again, let's find out A11. I'm dealing each and every process for you so that don't get ever confused how to deal with this. The first row and the first column, leave this, I'm explaining once again, 1, 3, 2 and 4. So same way, first row and the second column, meaning take up the first row, this is my first row along with the second column, leave this, they are left with 2, 3, 1 and 4. Now this is 1 and 2, that is, if we add up them, this becomes an odd number, this was even. So same way, 1, 3, the first row and the third column, that is given by, leave this, you are left with 2, 1, 1 and 2. So you'll get this as, solve this, 4 minus 6, that is equals to minus 2. This becomes minus 8 minus 3, that is equals to minus 5. This becomes 4 minus 1, that is equals to 3. Since it's not going to fit out here, I'll rub the board again for you. Should I rub the board here? To rub the board. Same way. Take up the second row along with the first column. Take up the second row along with the first column. Second row along with the first column. You are left with 3, 1, 2 and 4. Since 2 and 1 is odd, so you will write negative. That becomes minus 12 minus 2. That is equals to, you will get that to be minus 10. Again, second row, second column. Take up that. If we take the second row, the second column, leave this, you are left with 5, 1, 1 and 4, that is equals to 20 minus 1, that is equals to 19. Take up the second row and the third column, that is odd. I'll write this as, leave this, leave this and leave this, you are left with 5, 3, 1 and 2, that is to minus 10 minus 3, that is equals to minus 7. Again, come with the third row along with the first column, that is 3 plus 1 is 4. Leave this, you are left with 3, 1, 1 and 3. That you land up to 9 minus 1, that is equals to 8. Take up another one, that's third row and the second column, 3 plus 2, 5 minus, you land up to, leave this and leave this, you land up to 5, 1, 2 along with 3. You will get this to be minus 15 minus 2, that is equals to minus 13. Along with land up third row, the third column, you will land up to, you will get this to be, take up this, leave this, you will get 5, 3, 2 and 1. I'll clean the board for you and you will get this to be 5 minus 6, that is equals to minus 1. Now, since I got a value of the cofactors, now I'll substitute the cofactors and find out A inverse. So A inverse is equals to, I got with that along with the determinant I got, I think so, minus 1 by, how much did I get? Minus, what was the value of the determinant? I don't remember right now. The value of the determinant was minus 1 by 22. Minus 1 by 22 along with the adjoint. Adjoint is how much? I've got this to be minus 2, minus 5, 3 along with minus 10, minus 10, 19 along with minus 7. Again, this becomes 8, this becomes minus 13, this becomes minus 1. This is the value of A inverse. But to find out, you don't have to find A inverse only, you have to find the values of X, Y and Z. So I'll write, after completing all these things, so I'll write X is equals to A inverse into B. X was given by X, Y, Z. A inverse, which you have found, minus 1 divided by 22 with along with minus 2, minus 5 and 3, minus 10, minus 19, not minus 19, minus 7, 8, minus 13 along with minus 1, and the value of B was, I think so, what was the value of B? B was it 16, 19 along with 25. This is the value of B. Now, this is multiplication, which I already taught you. This is the matrix of 3 by 3. This is the matrix of 3 by 1. 3 rows and 1 column. Is multiplication possible? Absolutely. So I'll write this as minus 1 divided by 22. Now multiply minus 32 minus 190 plus 8 5 is 40, 8 2 the 16, 200. This is 3 by 1. This becomes minus, plus into minus, 16 5 is 80, 19 19 is plus 361 minus 25 minus 25 3 is 75, 7 in my hand, 7 in my 25 plus 7, 32. This becomes 32 minus 17, 19 into 7, 7 9 is 63, 6 in my hand, 7 1 is 7 plus 6, 133 minus 25. So you get this as minus 1 divided by 22 along with 200 minus 122. This becomes minus 22. This becomes minus 380, 405 minus 445 minus 361. You'll get minus 44. this becomes 32 minus 158. 32 minus 158, that becomes 66. No. 6. 158. 126. So you'll land up to, this becomes, now simply multiply minus 1 by 22, this you'll get to be minus 1 by 22 into minus 20, this becomes 1, this into this becomes 2, this into this becomes 5. So this is the value of x, y and z. So you'll write therefore x is equals to 1, y is equals to 2 and z is equals to 5. That's my solution.